the number appearing on the die should be different, as well as the sum of the dice number should be equal to 4. Then the only possibilities is 1, 3 and 3, 1. When we are calculating the probability where B is already happened and we need to calculate the probability of A, if we are calculating the probability of a complementary event, so we know that the probability of any complement of event, that is E dash, is 1 minus P of E. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. So we are at the last chapter, number 13, probability. So the very first concept you are going to study under the probability this year is conditional probability. So in this session, I am going to brief the explanation of conditional probability and the problems related to it. So what do you mean by conditional probability? Now let us take an example of rolling a die. We know the sample space of rolling a die as 1, 2, 3, 4, 5, 6. Let me consider an event A where we say 1 occurs. So I'm taking an example of an event where 1 occurs when a fair die is rolled. Then what is the probability of A? So probability of A is 1 by 6. Now let me take another event which says odd number occurs. We know that the odd numbers among the die is 1, 3, 5. So when I say the probability of getting an odd number, then obviously the probability of B will be 1 by 2. That is 3 by 6, which can be written as 1 by 2. Now, I'll modify the statement that what is the probability? So, what is the probability of getting 1 when odd number is already occurred? So here I need to calculate the probability of 1 where the odd number is already occurred among the die. So here there is a modification or there is a condition which is implemented on getting 1 when a fair die is rolled. So this type of probability, that is an imposing a condition on certain probability, is nothing but conditional probability. So I'm getting a condition to get 1 here. So here my sample space will be reduced into the event B. So we can clearly see here, to occur event A, event B has to be happened before. See the question, what is the probability of getting 1? That means probability of event A when odd number is already occurred, where probability B is already occurred. That means we need to calculate the probability of event A given B is already happened. So when we say B is already happened, my sample space reduces to 1, 3, 5. So when we are calculating the probability where B is already happened and we need to calculate the probability of A using this as a sample space, then the probability value will be equal to 1 by 3. It is not equal to 1 by 6. So clearly you can see here, I am calculating the probability of 1 where probability of odd number being 1 by 2 and we say event B is already happened. So this type of probability is called as conditional probability. That means I am calculating the probability A where B is already happened or given that B is already happened. Now let's also check here. So we know that the event A has an outcome 1 here. And now see here, when we take A intersection B here, the common element is 1. So clearly, probability of A intersection B is equal to 1 by 6. Now when I say here, probability of A given B is already occurred, this 1 by 3 is nothing but probability of A intersection B divided by probability of B. So probability of A intersection B is 1 by 6 and probability of B is 1 by 2, which when we cancels, that is equal to the value 1 by 3. So theoretically, given that probability of A given B is already happened, can be written as probability of A intersection B divided by probability of B. In a similar way, if even we have to calculate the probability of event B, given that A is already happened, then it is given by the formula probability of A intersection B divided by P of A. This can also be reduced using the number of elements inside A intersection B as well as P of A. So that is probability of B over A can be written as N of A intersection B divided by N of A. That is, we can also use the concepts of cardinality here. So for instance, I have told you we have a sample space of throwing a die from 1 to 6. Let A be the event 1 occurs and B be the event of getting odd number. Now if I want to calculate the probability of A conditional B, then that can also be written in the form of N of A intersection B divided by N of B. We know that there is only one element in these two events, that is 1. So the cardinality will be 1, and odd numbers means the value of N, that is the cardinality of set B, will be 3. So obviously it is 1 by 3. The same thing when we expressed in terms of probability also, we can write it as probability of A intersection B over P of B. So now we have the actual definition here. If E and F are two events associated with the sample space of a random experiment, the conditional probability of the event E given that F has occurred, that is P of E given F, is given by probability of E given F, or E conditional F is equal to probability of E intersection F divided by P of F. So clearly it is very easy to remember the formula here. If E given F is already happened, then the denominator will be P of F. If F given E is already happened, then the denominator will be P of E, provided the numerator value is the probability of the simultaneous occurrence of both events, that is probability of E intersection F. So remember, the probability of F when calculating E or probability of E when calculating F, those two are non-zero probability. So they have to be greater than 0. Now some properties of conditional probability here. So the first property is probability of sample space given F is an event, then it is equal to the value 1. So when you are calculating the probability of the sample space, so that event is already happened, F is an event which has already happened, then we know that probability of S given F is happened can be written as probability of S intersection F divided by probability of F. We know that S is the superset. So when you intersect S intersection F, then we obviously get probability of F divided by probability of F, which is equal to 1. In the similar way, if A and B are any two events of a sample space and F is an event such that probability of F is not equal to 0, then we can apply the conditional probability of the existence of A union B, that is simultaneous existence of A or B. A or B. Conditional F, or given that F is already occurred, is equal to P of A given F is occurred plus P of B given that F is occurred minus probability of A intersection B given F is occurred. So the last condition is, if we are calculating the probability of a complementary event, so we know that the probability of any complement of event, that is E dash, is 1 minus P of E. So when you are imposing a condition F there, then it is obviously probability of E dash given F is equal to 1 minus probability of E given F. So now let us take few examples. If probability of A is equal to 7 by 13, probability of B is equal to 9 by 13 and probability of A intersection B is equal to 4 by 13, evaluate the conditional probability of P of A given B is already happened. So P of A given B is equal to probability of A intersection B divided by probability of B. So A intersection B is given as 4 by 13 and probability of given as 9 by 13. So the value is equal to 4 by 9. Next question. If P of A is equal to 0.6, P of B is equal to 0.3 and P of A intersection B is equal to 0.2, find P of A given B. So probability of A given B is again probability of A intersection B divided by P of B, which is given as 0.2 divided by 0.3, which can be written as 2 by 10 over 3 by 10. So the value can be written as 2 by 3. Next, if probability of A is 0.8 and probability of B given A is equal to 0.4, then find probability of A intersection B. So using this, probability of B given A is equal to 0.4. So B given A can be written as probability of A intersection B divided by P of A, which is equal to 0.4. So probability of A intersection B is equal to 0.4. If you multiply probability of A here and its value is given as 0.8, so 0.4 into 0.8 can be written as 0.32. So this is the probability value of simultaneous occurrence of event A and B. Next, a family has 2 children. What is the probability that both the children are boys given that at least one of them is a boy? So let us consider the sample space of this experiment. A family has 2 children means it may be both boys, one boy, one girl as elder and younger, or girl, boy, or both are girls. Now let us consider an event E where both the children are boys, that is B. And let F be the event where at least one of them is a boy. So the thing is, both are boys, B, G or GB. Now clearly here when you calculate the probability value of E, it is 1 by 4 and probability of F, it is 3 by 4. Now we need to calculate the probability of both the children are boys given that at least one of them is a boy. So that means probability of E given F is occurred. So therefore this is equal to probability of E intersection F divided by P of F. So we know P of F here. Let's calculate probability of E intersection F. So the common element in both the set is BB. So therefore probability of E intersection F will be equal to 1 divided by 4. So now if we substitute here, it is 1 by 4 divided by 3 by 4, which is equal to 1 by 3. See, the same thing can be used with an alternative method, that the probability of A over F can be written as number of elements in E intersection F divided by number of elements in F. So number of elements in E intersection F is only 1. So that is 1, and F it is 3. So 1 by 3, which will be one and the same. Next, a die is thrown 3 times. Events A and B are defined as below. Event A says that 4 on the third throw. Event B, 6 on the first, 5 on the second throw. Find the probability of A given that B has already occurred. So we need to find out the conditional probability of A given B is already occurred. So which can be written as probability of A intersection B divided by probability of B. First let us find out what is event A, event B and A intersection B. Now event A, which says 4 on the third throw. So when you are throwing a dice, it is obviously 6 into 6 into 6. That means you have a total outcome of 216 elements. So that is the cardinality of your sample space is 216. So now we need to calculate A. So A, for instance, it may be 1, 1, 4, 1, 2, 4 until 1, 6, 4. Similarly, it can be like 2, 1, 4 to 2, 6, 4. Because I need 4 on the third throw. So 3, 1, 4 to 3, 6, 4. Similarly, 4, 1, 4 to 4, 6, 4. And 5, 1, 4 to 5, 6, 4. And the last is 6, 1, 4 to 6, 6, 4. So when you clearly observe this event, it is 6 cross 6. So therefore, cardinality of A will be equal to 36. Now let's calculate an event B. So B will be 6 on the first throw, 5 on the second throw. So that has to be 6, 5, 1, 6, 5, 2, 6, 5, 3, 6, 5, 4, 6, 5, 5 and 6, 5, 6. So therefore, here we have only 6 elements, that is n of B can be written as 6. Now we need A intersection B. So in both the cases, we should have 4 on the last throw. So consider here 4 on the third throw, 6 on the first, 5 on the second. So the only possibility is 6, 5, 4 in both the sets. So therefore, n of A intersection B will be only this element, which is equal to 1. Hence, the probability of A over B can be written as probability of A intersection B divided by probability of B, or n of A intersection B divided by n of B. So n of A intersection B, number of elements in A intersection B is 1 and number of elements in B is 6. So the probability value is 1 by 6. Next question. Mother, father and son line up at random for a family picture. Event E determines son on one end. Event F determines father in the middle. Determine E given F is occurred. So we need to calculate the probability of son on one end given that father is in the middle. So when I say E, the set E can be written as son at the corners. So father, mother, or son, mother, father, or mother, father, son, or father, mother, son. So son should be at any one of the corners. Now F. Set F can be written as son, father, mother, or mother, father, son. Now E intersection F. That means son should be at the corner, father should be in the middle. So the only possibilities is son, father, mother, mother, father, son. Now to calculate probability of E over F, so it's enough to write cardinality of E intersection F with respect to F. So clearly we have 2 here and 2 here. Hence the probability value is equal to 1. Question number 7. Assume that each born child is equally likely to be a boy or a girl. If a family has 2 children, what is the conditional probability that both are girls given that the youngest is a girl? Second one, at least one is a girl. So we have to calculate the conditional probability of both are girls with the first, the youngest is a girl, and the next one is at least one of them is a girl. So now here, let me calculate A so that both are girls. So therefore, it is G. Now here, probability of A is 1 by 4. Now let me denote this event as E and this event as F. First, let me calculate probability of A over E. It should be probability of A intersection E divided by P of E. Now first, let us find the set E. So set E is equal to, the youngest is a girl means the possibility or boy, girl, girl, girl. So now you intersect A with E, we have G. So clearly the probability of A intersection E is 1 by 4 and probability of A. So if you calculate probability of E here, it is 2 by 4 which is equal to 1 by 2. Now if we apply here, so 1 by 2, can cancel this. The value is equal to 1 by 2. Now let us keep the set A as G, G. Now for the second one, let me consider this as F. F says at least one is a girl. So therefore it has to be boy, girl, girl, boy, girl, girl. So clearly probability of F is 3 by 4 and A intersection F is only girl, girl. So obviously probability of A intersection F is 1 by 4. So therefore probability of A given F is occurred is probability of A intersection F divided by probability of F, which is 1 by 4 by 3 by 4, which is equal to 1 by 3. Next question. Given that the two numbers appearing on throwing two dice are different, find the probability of the event. The sum of numbers on the dice is 4. So now, given two numbers appearing on the dice are different. Suppose if x comma y is the sample space, then the two dice should show different numbers here. So it cannot be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6. So if I consider this as an event A, then number of elements in A is equal to 36 minus 6, which is equal to 30. So now the next thing is, I'll consider it as an event B so that the numbers appearing on the dice is 4. So the number appearing on the die, the sum of the numbers is, the only possibility is 1, 3, 2, 2 and 3, 1. So now clearly here n of B is equal to 3 divided by 36 and here this is equal to probability of A, which is 30 divided by 36. Now if I consider A intersection B, that means the number appearing on the die should be different as well as the sum of the dice number should be equal to 4. Then the only possibilities is 1, 3 and 3, 1. So therefore probability of A intersection B is equal to 2 by 36. Now I need to calculate the probability of B given A is happened. So that is, we need to calculate the probability of sum of numbers on the die is 4 so that the numbers showing on the dice are different. That is, P given A is already happened, which is nothing but probability of A intersection B divided by probability of A. So which is equal to 2 divided by 36 over 30 divided by 36. So when we cancel this, we'll get the value as 1 by 15. Next question. An instructor has a question bank consisting of 300 easy true or false question, 200 difficult true or false question, 500 easy multiple choice question and 400 difficult multiple choice question. If a question is selected at random from the question bank, what is the probability that it will be an easy question given that it is a multiple choice question? So now first let us see the number of questions, that is n of s, which is 300 plus 200 plus 500 plus 400, that is 1400 question. Now next, let E denote the events of easy question and F denote the events of multiple choice question and E intersection F denote the event easy multiple choice questions. So now when I say easy questions, we have 300 easy true or false and 500 easy multiple choice questions, so total 800. So therefore probability of an event E will be equal to 800 divided by 1400. And next is multiple choice question. When I say multiple choice question, we have 500 easy and 400 difficult. So in total, probability of F is 900 multiple choice question out of 1400 questions. Now when I say E intersection F, that means it has to be easy as well as multiple choice question. So there are only 500 easy multiple choice question. So therefore, probability of E intersection F is 500 divided by 1400. Now I need to calculate the probability of an easy question given that it is a multiple choice question. So therefore, probability of E given it is a multiple choice question, that is given F, then it has to be probability of E intersection F divided by probability of F. So E intersection F, we got it as 500 by 1400 whole divided by probability of F as 900 divided by 1400. So we can cancel the denominator, cancelling zeros. The value of the probability is equal to 5 by 9. So today in this session we have discussing the imposing condition on the respective probability, that is to calculate the probability of one event when the other event is already occurred. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.